Welcome, Math Models. This is Miss P, and welcome to the normal distribution and z-scores. We're going to do a basic introduction of these topics, and if you choose to take statistics, you will learn even more about them. So for your little quick sketch or quick reminder, you may want to put a graph that looks like this. And if you need help drawing it, those one are right there. So it's called a bell curve. And you've got your mean in the middle. And then you may want to also put a formula for the z-score, which is something that we're going to talk about. It's z equals, and then just x. Then your population mean, it's the Greek letter mu. So it kind of looks like a U, but it's got a leg. It's got legs. It's a U with legs. And then over our old friend sigma, the standard deviation. So I would suggest putting these things on the front so you have a quick glance summary of it. So I've got a diagram here of the normal distribution. And it's something that comes up a lot in heights of people, weights, medical test scores a lot of the times, SAT scores, ACT scores. So there's a lot of different big data groups that get used a lot that end up being a normal distribution. So if you take a statistics class, you're going to be doing a lot of this, a whole lot about this distribution. And we're just going to kind of introduce it to you and give you a taste of it. So in my graph, my distribution graph here, I have the mean, median, mode approximately equal in the middle. And then over here, I've got the mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviations, and so on. And then on this side, I'm subtracting. So we're going to be filling this out here in just a minute with an example here from these numbers, and then an example with some SAT and ACT scores. So first, we're just going to use the TI Inspire to find the mean and standard deviation of the data set below, and we're going to go ahead and use the population standard deviation, not the sample. And then we're going to round to the nearest tenth and use statistics to complete the normal distribution diagram above. So I've already done it for you. Got it here. You may want to pause the video and make sure you remember the steps to do it, but then you can go ahead and keep playing and just look at what I've got. So I called my data list X, and then I've got my statistics right here. So my mean rounded to the nearest tenth is going to be 7.2. So let me write that down. I'll put that here too, 7.2. And then my population standard deviation, so remember you're looking for sigma. So scroll down, because this is the sample standard deviation. I don't want that one just for this problem. I want that one, 1.9. So equals 1.9. Okay. So what this means here is that if I go one standard deviation up from the mean, I'm taking 7.2 plus 1.9, which gives me 9.1. So one standard deviation above the mean would be 9.1. And then go ahead and take what you got there and add another standard deviation to it. All right, so our mean is 7.2. One standard deviation above the mean is 9.1. Two standard deviations above the mean is 11. And three standard deviations above the mean is 12.9. And then we're going to subtract. So I'm going to take 7.2 minus 1.9, which gives me 5.3. So that means 1 standard deviation below the mean is 5.3. Then take that guy and subtract 1.9 again. And I get 3.4. And then take 3.4, subtract 1.9 again, 1.5. So you're going to be doing some of that, usually in more concrete contexts like with the SAT score, but we wanted to start out with some smaller numbers. Okay, now let's move on to the z-scores. Z-scores are kind of cool. A z-score helps you compare data sets that are very different. For example, SAT scores and ACT scores. It tells you how many standard deviations above or below the mean your points are. So for example, if somebody had an SAT score that was 2 standard deviations above the mean, that means that person did way above average. So we're going to look at a specific example here with Darren. So Darren took the SAT and the ACT in 2017, and this is real data. Darren is made up, but these are real numbers. So the mean SAT score in the US in 2017 was 1060 with a standard deviation of 195. The mean ACT score was 21 with a standard deviation of 5.6. Now look at how different those values are. Those are completely different scales. Like this score and this score don't look anything alike. So how are you supposed to compare them together? Darren scored a 1250 on his SAT and a 28 on his ACT. On which test did Darren score better compared to the US as a whole? So maybe Darren just wants to send his best score into colleges so that he has a better chance of being accepted. So which score would he want to emphasize? Which one is the better score? This one looks like a bigger number, but is it better than a 28 on the ACT? I don't know. We're going to see. So we're going to use this z-score formula right here for both tests. So let's look at his SAT first. So you're going to put z. Z is what we're looking for, so just leave it as a variable. And then you're going to take x. Now x is your data point. So in this case, that means Darren scores. And on his SAT, he got a 1250. So put 1250 minus, now we need the mean SAT score, which we read about right here. The mean SAT score was 1060. So put that right here. And then we're going to divide that by sigma, which is the standard deviation, which we saw here was 195. Okay, then put that in your calculator. I did it for you already. And you get 0.97. Okay, so that's for his SAT. Now here's what that means. This is 0.97 standard deviations above the mean. So remember that number, because I'm going to move my paper. Now, here's 1 standard deviation above the mean. These are your z-scores right here, basically. This is where they fall. All these people, these guys did better than average. Okay, so all of these guys, here's my average. Let me draw my average in. Choop, that's average. These guys all did better than average. Yay! All these guys, they did worse than average. So where's Darren in this? So Darren, as we said, he was 0.97 standard deviations above the mean. So where is 0.97 going to be on here? Well, it's a positive number, so he did better than average, but it's not quite 1 standard deviation. It's just slightly below. So like right here. This is Darren. Darren's SAT score was right about right there. So he did a pretty good job. He did better than average. But all these people still did better than him. These people did a lot better than him. So he's got a pretty good thing going with this SAT score there. But let's see if this ACT is better. So let's go back down. In fact, I'm going to put the number there. Z equals 0.97 right there. All right. So let's look at ACT. So Z equals our data point. So Darren's score was a 28. So put 28 minus the mean, which the mean ACT score was a 21. So we're going to subtract 21. And then divide by the standard deviation. So the ACT standard deviation is 5.6. Okay, let's see what we get there. Okay, so for his ACT, Darren was 1.25 standard deviations above the mean. Now check that out. We couldn't compare these scores directly because they're on completely different scales. The SAT is out of a bigger number than the ACT, so this number is always going to look bigger. But once we make the scales the same with the Z-score, we can see that Darren's ACT score is actually better than his SAT score compared to the whole US. So let's see where that fits on our diagram. So remember 1.25. Okay, so here's one standard deviation right here. He didn't quite reach 2 standard deviations, but I'm going to write in a different color. So kind of like right about here, that's Darren's ACT score with a Z value of 1.25, a Z score of 1.25. So his ACT score is further along compared to the average than his SAT score. So actually he did better on the ACT. All right, so we're going to be doing more of this in class, looking at more Z scores and what they mean. And thank you for watching.